So hello everyone, this is Aditya Mishra, and this is our first class or lecture series meant for students, those who are actually interested in understanding aerodynamics, also those who are willing to go for or planning to take aeronautical engineering or motion of flight vehicles in their higher education, or looking for jobs in this engineering sector. This class will be very useful, this lecture will be very useful. Also it is helpful for all the students, those who are willing to appear for gate exams or crack gate examinations in aeronautical stream. So first and foremost question that will come in our head when we are talking about aerodynamics is, what is aerodynamics? So the word aerodynamics itself, it comes from two Greek letters. The first one is known as eros, and the second is called dynamics. Eros means air and dynamics means motion. So aerodynamics basically means motion, response, or behavior of a fluid as it moves over a solid surface, or it flows, or maybe a solid object when it moves through the air, vice versa. Okay. In general, we can talk about aerodynamics is applicable to airplanes, motion of airplane, helicopters, rocket, missile, bus, train, or a car, anything or any object actually which moves through the air. Not only the flying vehicles, anything which has to pass through the air, or which is in the atmosphere, open to free atmosphere, right? Particularly you can see the applications, we can see the applications of aerodynamics, especially for design purposes. Okay, for design studies, better simulation studies. It is useful for even trains and rocket or missile aerodynamics. Building construction is also, in building construction also aerodynamics plays a very important part, especially if the building is very tall. Okay. And obviously it is useful for uh, designing the objects to respond for better efficiency. Then particularly in aeronautical engineering, we talk about airplane aerodynamics. Okay, whenever an airplane moves through the air, how the air responds to the shape of the object or the design of the object, what actually affects the movement of the air or the speed of a vehicle when it is moving through the air. Now airplane is so first and again the second question is, what is an airplane? Airplane is basically any flying object or any object which is moving through the air with a fixed wing. It has a wing which cannot be deformed, or which cannot be distorted, which cannot be bent. A wing of such kind will be is called as a fixed wing. And study of behavior of fluid, or motion of response of fluid when it moves through the air, the flying object or an airplane moves through the air, is focused in this engineering discipline. Okay. Nowadays people are also started looking, the scientists have advanced level up, and they are looking for deforming wings or flapping mechanisms like bird flight. Here we can see basically the stream aerodynamics actually has originated from for mimicking the flight of bird, or the human you can say aspirations of flying like a bird or in the air. Okay. So therefore this is a useful development actually. Then what is aerodynamics? Before getting into detailed study of behavior of an air as it moves past a solid object, actually an object which is flying through the air, when we talk about aeronautical engineering, or an airplane which is moving through the air, or the performance of the vehicle. okay, lift, drag, pressure, the properties which actually affects the performance or efficiency of a flying vehicle. Nowadays, actually the attention has also been focused on the maneuverability. Okay, so these aeroplanes or aircraft has to work, or even nowadays drones are there. So these or even the blades of a turbine or a propeller, they have to function at different angles and under very different situations. Okay, uh, the natural situation could differ from what has been actually taken in the studies when actually it is being designed. So the understanding the off design performance is also one of the most important part of design of an object. Then it is also like I said, it is important in designing the flight vehicles or air vehicles or even the air vehicles which are able to perform like wind turbines for generating electricity. Many other objects are also useful. For example, a pillar or a cylinder which is standing in air, it is also important for calculating the performance of such a design and how long it is going to last. Will it be able to sustain the forces of air which is acting on the object? Then it is meant for theoretical, experimental and numerical calculation. Most widely actually numerical and theoretical calculations are preferred nowadays. Most of the corporate jobs are mainly focused on these two areas, especially in numerical calculations when we talk about softwares. Okay, experimental calculations are useful to study new designs or validate the numerical or theoretical studies against the experimental or real life results on of the experiments on prototype. Then before getting into details of aerodynamics, we'll quickly see some of the fundamental ideas that is needed to come advance in this study of aerodynamics. First is what is the difference between an ideal and a real fluid. Then compressible, what is compressible and incompressible flow. Third is the basic idea of what exactly is boundary layer. Okay, is very important. Then what is for from aeronautical engineering or flight design purposes, it is very important to understand the difference between a finite or a two-dimensional wing and infinite or a three-dimensional wing. So quickly we will see in this first lecture this basic concepts which are important. What is an ideal and a real fluid? Ideal fluid is basically a hypothetical concept, a standard which is set by a scientific society so that it can differentiate between the real fluid and an ideal fluid. And I hope that everyone knows by now because we are planning to appear for GATE exams. So a fluid is basically a substance which undergoes continuous deformation once an external force is applied. Okay, and one of the three most important properties of any fluid, if we are interested in studying about gas or maybe it is interested in studying about liquids, three most important properties useful in real life applications is density, viscosity and interfacial tension. Density is basically how compactly the fluid is arranged, or what is the number of molecules present in a cubic 1 meter cube of space. Or viscosity is basically the ability or decides the ability or tendency of the fluid to flow. Higher viscous liquids actually they try to resist the motion of a fluid, and less viscous liquids they flow very easily, they cannot be also compressed. So viscosity, based on viscosity we divide fluids into Newtonian and non-Newtonian fluids. And third very important aspect of fluid mechanics or fluid studies is interfacial tension. In almost all kind of real life applications, interfacial tensions does exist. Okay, because the liquid is open to interact with the atmosphere. So interfacial tension plays a very important role. Now when we say an ideal fluid, there is a set of properties which are given for to be called a fluid, an ideal fluid. first one is density has to remain constant. Okay, most importantly, because number of molecules present in a given volume or given space should not change with position or with time. Such a liquid actually will be also, it is also called as an incompressible fluid. Then second important thing is viscosity. Like I told you, it is one of the most important property when we talk about energy transfer in the fluids, or when we talk about motion of a fluid. It has to be very importantly paid attention to. Okay, and third one is interfacial tension. Like I told you that in all kind of real life applications, when the liquid is open to interact with the air or open to atmosphere, surface tension is very important part, and it can never be zero. So any fluids which behave or which has property other than which is all the three properties stated here, they are called as real fluid. Okay, so this is ideal fluid is basically a standard or a concept which is designed to differentiate between the real and ideal fluid on paper. Okay, it has no real life applications actually. So compressible and incompressible fluid, like I told you, incompressible, a fluid flow, basically a flow of a fluid, or a flow in which the density cannot be changed by any means, or the number of molecules present in a given volume remains the same. Such a flow is termed as an incompressible flow. Then let's talk also compressible flow, because density is constant here. There are certain conditions under which the density keeps on changing. So a fluid flow in which the density keeps on changing, or the density of fluid is actually variable, such a flow is known as a compressible flow. Now we know what is incompressible and what is compressible flow. The density is constant, so incompressible. If the density varies or changes along the flow or in the flow, then it is called as a compressible flow, which we will see generally in gas dynamics. We'll talk about compressible flows, or the changing liquid of density of a liquid. Then second most important concept is what is boundary layer, right? So whenever air or any liquid, whether it is water or whether it is gas, whenever it moves over the solid object, there is a very thin region which is in very thin region of fluid in contact with the surface of the solid object, whereby the viscosity becomes very important. Or viscosity plays a very important role in you can say damping the motion of air, or the motion of a fluid which is trying to pass. So a small region, as you can see here, a very small region whereby the viscosity is important, or you can say flow properties undergoes variation, especially the flow velocity, when we are talking to aeronautical, with respect to flight and aeronautical engineering, or turbines or turbo machines. This becomes a very important area to look upon. So basically boundary layer is a very small region, which is when region of the fluid which is in contact with the solid surface, whereby the viscosity of the fluid plays a very important role. Okay, so everything which is, so this thin region here, it is visible in blue color. This if this region we are calling it as boundary layer, then the liquid which is outside the boundary layer is actually remains unaffected, and it moves with uniform stream. Only the region which is in contact with the surface, only the behavior of fluid when it is in contact with the solid surface undergoes variations, and everything outside this region boundary layer, it is treated as an ideal fluid. Like I told you, it is a hypothetical concept. So because we don't want to touch in that region, and it is not our interest to get into the details of that region, we will treat it as the potential flow. That is also called a potential flow. An ideal fluid flow is also known as a potential flow. Then so a boundary layer is basically a small region which the viscosity or flow properties vary, so abrupt behavior. Then coming to differentiating between 2D and three-dimensional wing, 2D or infinite wing, 3D or finite wing. Wing is basically a shape designed. This is actually a regular wing, a rectangular wing, as you can see. The wingspan is basically length of the wing between the tips. So the port side and the starboard side tips, when they are the distance calculated, that is called as a wingspan. And the chord is the length of the wing, as we can see in this picture. The horizontal length is wingspan, the vertical length is chord, and the shape of the wing actually keeps on changing depending upon the application of the airplane. If it is a fighter jet, the shape will differ. If it is a commercial plane, the shape is going to differ. And one of the most important properties that we should pay attention is when talking about design of a wing or airplane design for a given purpose, we have to pay attention to this thing, which is called aspect ratio, a formula. So basically a wing has wingspan, which is the length between the wing tips, and the cross section or vertical length of that wing, of a given wing, is called as chord. Then what is different between 2D and 3D wing? 2D wing is again a hypothetical concept which has been used for calculating the flow properties when the flow moves in two directions. Okay, and but in real life the flow is all, even the objects are three-dimensional. So 2D wing is basically a wing without wing tips. So practically it is not possible for a wing to have an infinite length or which has an infinite span. Okay, but for under laboratory conditions it is possible to actually represent this kind of a wing which has no tips. We'll discuss this. And 3D wing is basically wing with wing tips, a real life wings which is having tips. Actually, when a wing flows in real life, there are changes in the behavior of the wing, which is also known as 3D effect. So when in real life, when the wing tips are visible to the flow, actually in this case the wing tips are not experienced by the flow. A flow is not able to feel the presence of the end on either side. So it has infinite span, an ideal concept actually, but when come to a real life, the span should have a fixed value, it should have a finite value, and it should have a constant value. So a finite wing, right, a variable wingspan, actually I have not encountered in we have not encountered in any of our studies. So for the time being it is out of the concept, but people are actually looking into these aspects also. Then coming to 2D wing, like I told you, a 2D wing is basically a wing which has wing in which the air is not able to see or feel the presence of a wing. So in under laboratory conditions, whenever the studies are performed, the edges, the either edges or tips of the wing are connected to the wall, so that the flow is not able to move in the third direction. It is going to move, it is able to move in forward direction, and because of the presence of aerofoil shape or this wing shape, it is able to move in upward direction. So forward and upward direction the flow is able to move. That's why it is also called a two-dimensional wing. A two-dimensional wing is also known as an infinite wing because there are no end tips actually visible to the flow. So infinite wing, two-dimensional wing is basically a laboratory concept. Then the cross section of such a wing is used for all the studies. When we take the cross section of this particular wing here, it will show this kind of a shape which is known as an aerofoil shape. This shape has actually evolved for over many years of studies. A shape which is this is called an aerofoil shape, a shape which is designed so that fluid can actually a shape which is designed to generate lift. When an aeroplane is moved through the air, it can a shape which can generate maximum lift. That is what is the focus of an aeronautical engineer. Okay, then coming to finite wing, this is again the laboratory studies which is performed by keeping the wing vertical and attached to the walls of the wind tunnel or the laboratory setup. Then again you can see here that the wings are attached to the walls by means of this wooden attachment. Okay, so the tips are not visible to the flow. Okay, the flow here is able to come and it will be moving through over the aerofoil without even experiencing the presence of the tips. Then coming to a finite wing or three-dimensional wing, like I said, in real life actually every aeroplane should have a finite wing, otherwise it will become difficult for designing a wing or basically performing the studies also. Even this small simple aircraft, as you can see, this comes under a three-dimensional and finite wing. So I hope whatever we have discussed is very simple, easy and quick to catch concept. Thank you very much all of you for your time, and we'll meet in our next class.